So this integral is going to become integral. We have x plus 1 plus, we were going to have a over x plus 1 plus b over x minus 1, and then we're going to have c over x minus 1 squared. Right? That's what we were going to get. This last piece was going to turn into a over this, b over this, c over this. Right? Anybody want to go out on a limb here and tell me what a, b, and c are?
A, -1.
-1 for a?
1 for B.
1 for b?
2 for C.
Oh, those are nice numbers, so I feel pretty good about this. If you get some crazy decimals like, 0.2356783, like something's probably wrong. Because I'm going to make sure that on the test these numbers come out to be nice. I mean, they'll be, 1/2 maybe, right? But if you get like 0.276 and it's like some weird rational number, irrational looking, that's kind of red flag. All right, there we go. That's it. So now we can integrate this easily, this easily. This is a natural log. This is a natural log. This is not a natural log. It's a constant over repeated linear, which we know how to do. We can do this. This is like 1 over u squared. Remember there were 8 things I said we should get comfortable with. Do you see why now? I mean, it's because at this point we should be able to go straight to it. 1/2 x squared plus x minus natural log of x plus 1, nothing to compensate for there, plus nothing to compensate for here, natural log x minus 1. This one I'm going to have to think through a little bit. Let's see. Got a 2 that comes out front. I don't have to compensate for anything in front of the x because it's a 1. So that looks like 1 over u squared, which is really u to the -2. And the antiderivative of u to the -2 is negative u to the -1, which is -1 and then that to the -1. So something like that. So this is like negative, and then this is u to the -1 plus c. Just make that -2 and we're there. Questions, comments, concerns, complaints? That only took us 20 minutes. Yeah, that actually went pretty quick. So if we see distinct linear factors, a over the number, right? B over the number. If we see repeated linear factors, we've got to kind of build up the power, right? So what else is there? Something like that. So the next test that's coming up, not next week, but the following week. I would say there are 2 main ideas that are on that test. Trigonometric substitution and rational functions, or integration, not integration by parts, partial fraction decomposition. So this topic, and then trigonometric substitution. Because you know that when you do trigonometric substitution, you have to do trig integrals. Like you get everything to sine, cosine, tangent, whatever. So I'm not going to ask you to do an integral with sine, cosine, tangent because it's going to be built into the trig sub problems. Does that make sense? So there's really like 2 main types of problems that you're going to see on that test. All right, what about this? Do we need long division? No. Good, see, already, look at that. We're halfway there already. We don't even have to do long division. So I'm going to start by, I recognize right when I put it on, right when I saw it there, right when it was presented to you, you recognized right away this is a rational function. So you're already thinking partial fractions, right? Okay, and then you factor the denominator, and you have that, right? And that is all the factoring you can do. There is no more factoring to be done. You have in your denominator a linear factor, right? And then this right here is an irreducible, I'm just going to put IRR, irreducible, right? Quadratic. We have not seen that before, right? We have an irreducible quadratic. It's irreducible. Look, if it was reducible, then it would factor into 2 more linear factors, right? So then we would have 3 distinct linear factors. But this quadratic is irreducible, so we can't break it down further. So what's the process for something like this? So we're going to start with a over x. That's just for this one, right? Now for this one, if it's irreducible quadratic, you know what you put? What? Bx plus c over that irreducible quadratic. Now, let's consider this for a second. The way this is working, and this is kind of, I don't know, semi-deep thought here. When you rewrite this a over x, you have a constant over a linear, right? And remember that, how do I say this? The power on the top is 1 less than the bottom. Would you agree? Like this is linear, this is a constant. So the power up here is 0, the power on x here is 1. And we know that with differentiation, when you take derivatives, the power goes down by 1. You'll notice that I have an irreducible quadratic here. So what I do is I place a linear function above it because the derivative of a quadratic is linear. So what I'm trying to force to happen here is the u du, right? The u down here, the du to be up here. Eh. So if you have a linear, you put a constant on top. If you have a quadratic, you put a linear on top. If you had a cubic, you would put a quadratic on top. Now it would have to be ax squared plus bx plus c, but that's what you would do. Now we won't go past quadratic, but I'm saying this does generalize. If you have a 5th degree polynomial down here, you could put a 4th degree up here and then try and use the partial fractions. All right, let's do this one. Next step is to clear the fractions. So when I multiply both sides by this, over here, I just get the numerator. When I multiply this by the denominator over there, what am I left with? Just a times the x squared plus 4. Right? When I multiply this, now be careful here, when you multiply this side by, or that term by this, only the the x squared plus 4 cancels, right? And so you're left with the x, but you're also left with this, the whole thing. So I'm going to put in parentheses, bx plus c, and then you still have the x there. Just make sure it's in parentheses because that x has to pass through. Questions on the clearing? Can we shortcut here? Can we isolate things? Can you ever kill this off? Not unless you use imaginary numbers, right? We can't kill that off because nothing squared plus 4 is 0. No real number plus 4 is, no real number squared plus 4 is 0. So I think, look, we're having so much fun with our calculators, right? We paid for them, we may as well get some work out of them. So let's distribute this through, let's distribute that through, and let's just see what we have, all right? We've got 2x squared minus x plus 4, ax squared plus 4a plus bx squared plus cx. You know what I forgot to do is show you in the notes where it says to do that. Oh, here it is. If the denominator has an irreducible quadratic factor, then you will place a linear expression above it. Okay, now our irreducible quadratic was not 3 terms, it was only 2, but it was still not factorable, so it was irreducible. So we put ax plus b on top. I don't know if you can decipher that from those notes, but that's what it's saying. Where am I? Part D right here, right? All right. Did y'all get the matrix set up already? Let's see, this is 2x squared minus x plus 4 equals a plus b, x squared, plus cx plus 4a. We could actually get some of these things right now, but, you know, Like you can already see what A is because this has to be 4, doesn't it? So A is 1, but I mean, again, you got the calculator, you paid, you know, $50 for it or whatever. You may as well get some usage out of it. And it's good practice. And it's fun, let's admit it. All right, so our matrix is, or our system of equations is A plus B equals what? 2. Second equation is C equals -1. Be careful with that because it's a -1 over here. And then the last one is 4A equals 4. Oh, you know what? I think I'm going to have a change of heart here. We already know what C is, right? C is -1. And then we know A is 1, right? So I'm just going to go C is -1, A is 1, just dividing both sides by 4. And if A is 1, then this equation becomes 1 plus B equals 2, which means B is 1. So I didn't need my calculator for that. Got A, B, and C. Y'all good? All right. Questions? All right, so let's go and let's rewrite the integral. The original integral is integral A, which was 1 over x. Nice, I'm happy to see that. Plus B, which was 1. So just x plus c, but c was -1. So x minus 1 over x squared plus 4 dx. Now, how exciting is that? Isn't that awesome? Isn't that awesome? Can you integrate the first one? Yes. Am I insulting you by asking? Yes. Okay. Can you integrate the second one? How? It's not a number over. It's not a number over x squared plus 4. Otherwise, it would be formula 17. It's a linear over an irreducible quadratic. It's a linear over an irreducible quadratic. Oh, it's a linear over an irreducible quadratic. This was that one where I made the numerator look like the derivative of the denominator, yeah. Where I brought in that number. Remember, I did some magic on it first. That's what I'm going to do. Maybe. Let's see. Let's take a look at it. We might be able to get around it. Pardon? Where? Oh, like rewrite the bottom as like the square root squared? You could, yes. But I think that would be more work than you need to do. I think it would. Let's look at this. Maybe I can persuade you to just not work too hard on it. Let's see. How about this? God, we just kind of get lucky with this problem that things work out nicely. Watch. Can I split it like that? I can, right? Because you have x minus 1 on top, so you can do x over the denominator and then minus 1 over the denominator. And you see what's really nice about this one? This one is formula 17. Okay, this one, because now it's a constant over this. This one is just a basic u sub. Just a basic u sub, because the derivative of if you let u be the denominator, what's the derivative of it? 2x, right? And you got it there, up there, kind of? You're off by a little bit? I'm ready for the answer. That's dead. So we did not need to do that thing where we matched it up. We kind of got lucky. We would have been kind of in trouble had this been like x squared plus x plus 4. Then we would have had to have done what I did in class the other day. Okay, natural log of absolute value of x. Yes. Plus 1/2 natural log of x squared plus 4. Where'd the 1/2 come from? When you do your basic u substitution, u is x squared plus 4. The derivative is 2x dx, but you have x dx, so you divide both sides by 2 and you get a half. I'm not going to work through that. That's a basic u sub problem. I'm going to trust you can get that. And then on this one, this is the formula. Wait, hold on. Did I say 17? No, I wrote minus instead of plus. Oops. That should be a plus. I don't know why I dragged that thing out and forgot it. Because had that been minus, it's not formula 17. It's formula 20 or something like that, right? Okay, so because it's plus, we're happy. What's that again? 1 over a arctan of x over a? So 1 over, what's a? 2. So 1/2 arctan of x over 2 plus c. Formula 17 from here to here. I'm thinking of, have y'all seen, what's the Rocky, the one with Ivan Drago, the Russian guy? Is that Rocky? Is it 4? Let's see. First one was, of course, the first one. Apollo Creed.
Third one was
Clubber Lane, the Mr. T, right? Okay. No, I'm thinking of, I think it's Rocky 4 with the Russian guy where he's like, he gets mad. Rocky gets mad, you know, and he's like, "You're not so bad," you know. He's like hitting him. He's like, "You're not so bad," and he keeps coming at him. You know what? That scene.
Lane, where he's like,
is it?
Yeah,
is it
like,
Clubber Lane?
He's like, "I'll show you what a real man is," and then like he turns to his wife. He's like, "Hey, how about I take you home later?" He's like, "Oh yeah."
Okay, we've got the Rocky aficionado over here. Yeah, I don't know. I don't know why I'm thinking of that. It's like these integrals are like they just keep coming. You know, we just keep coming too, right? Right?
Rocky's
Not so bad. We can get it.
Near and dear to my heart.
Kind of got out of control after about the 4th one. I think it got a little out of control.
Oh yeah, with his son being involved.
Yeah. All right. Well,
I don't think like half the people know what we're talking about.
it's all right. It's all right. All right. We talk about First Blood. We can talk about First Blood.
Oh,
Okay. Rambo, original. Okay, let's get back to this. Here we go. What do we have here? Long division first, right? Man. Okay. Do you say you're going to need rehab after this? Is that what you said? After this class, you're going to need rehab? Yeah. Remember, I'm the messenger. I've been saying that all semester. I am the messenger. I'm just here to help deliver the message. This is the Calculus 2 message. All right, what do you multiply 4x squared by to get 4x squared? 1. Okay, so 1, then it's just going to come down here and subtract, which means change the signs. X, and then minus 1, right? So that's our remainder, because you can't go any further, right? So plus x minus 1 over 4x squared minus 4x plus 3. So this original integral is 1 plus x minus 1 over 4x squared minus 4x plus 3 dx. Pardon? Okay, so good. You recognize that you have a linear over a quadratic, right? So maybe there's a way that I could like tweak this one up here to make it look like the derivative of this down here. That is the method that we use if the denominator is not reducible. Okay? If it factors, then we want to go with the partial fractions. So does the denominator factor? When you have a constant over a quadratic, that's when you would do that. Just a constant over the quadratic. That's irreducible. Yeah, you have to scroll back up, and now you can kind of maybe have a little bit more appreciation for this stuff over here. So when we had, linear, whatever, okay. Constant over a quadratic with no x term, formula. Constant over irreducible quadratic, complete the square. Linear over irreducible quadratic, magic. Okay? Hey, wait a minute. That's the problem. That's that problem. So, yeah. So I will defer to your notes, your previous notes. So if you go back in your notes, we did this, right, already? So that's what you would have to do. But then the answer would also have this in front of it, the antiderivative of this. So our answer would be ... see your notes. The antiderivative would be x plus whatever that was from your notes, plus c. Yeah, so I asked if this factored, right? I'm wondering how you're checking if it's factoring. I check it by multiplying a times c and getting 12, and then looking at the number in the middle, -4, and coming up with two numbers that would multiply to be this and add up to be this. And you just can't get them. 6 and 2 doesn't work because you would need -6 times 2, well, -6 and 2 to get this, but -6 times 2 is -12. So there would be no way to factor it. So you'd be stuck. So this was that one that I had to like try and make the top look like 8x minus 4. What am I doing here? I'm just trying to figure out if this factors.
I know what do you call it?
This is, well, there's different versions. It's like the AC method or something like that. X method, yeah. This is just like a little visual way to help when you're teaching this, like factoring. It's a visual way of helping organize the ideas. You're trying to find two numbers that multiply to be the product of this and this, and that add up to be the number in the middle. All right. I want to show y'all something here real quick on this problem. The long division on there wasn't too bad, was it? It wasn't too bad. Is that the same problem? It is, right? Like -4x plus x is -3x, and 3 minus 1 is 2, right? But do you see by me writing it that way, that if I put all of this over this, I get 1, and then plus, and then I get this over that? And that would have been the same thing I had with long division? Yeah. Right? If you see it, you see it. It's just to show you, like, there could have been a way we could have tweaked this a little bit and kind of played with the numbers to make it go here and not jump over that long division step completely. All right. What time is it? 15 minutes. Great. Perfect. So the homework for this assignment is 7 through 41 odd. And I have a take-home quiz for you. All right? Let me hand it out and then we'll talk about it. Oh, sorry. One more. And I apologize that the font is so small on this. It's font 12. It was font 12, but then when it printed, it looks like font 6. There you go. So I realize you have a lot of homework already. And like I said, I'm not sure what Thursday is going to look like for us. Okay? But I do want you to try these 4 problems and have them ready for next class. All right? Make sure you do all your work on separate paper, all right? So anytime you're given an assignment that's take home, please take into consideration that whoever's giving that to you is expecting for you to turn in like your best work. That means you've worked through the problem maybe, and now you've rewritten the problem to present it to somebody, right? I don't want to see all your scratch work and mistakes and, oh, I decided not to do that and now I went with this. I would prefer just to see your final work. Okay, so it should look somewhat neat, all right? So I would just start with paper, writing, trying to work through it, and then once you get it, rewrite it. Make it nice and pretty, right? It's not a rough draft that you're turning in. You're turning your final draft. Make sure your work is neat, stapled, and in order. So I should, turn it in, have your name, and stapled, and number 1, number 2, number 3, number 4. I know this seems obvious, but, okay? I don't want to talk about these problems at all. I don't want to give you any hints. I don't care if you work together, all right? But, however, I want you to just imagine that your test that's coming in 2 weeks is going to have like maybe 5, 6 problems on it, right? This is 4 problems. If you want to give yourself a good idea of where you are, maybe make sure you do the homework, get through a good part of this homework, then take this out and sit there with it and see how you do. Because that's what you're going to have to do in 2 weeks, basically, is have to come in here and do this. So don't just go run to the tutoring lab and, hey, this is a quiz, it's due, I need help, Don't go to each other and be like, hey, let's figure this out, It's all about you figuring it out. So do your best, and then if you can't, talk to your friends, talk to me, email me, text me, right? Enjoy. I guess that's it. I mean, you can work if you want. You can start work on now or you can leave. I'm not going to force you to be here. We're not going to start anything new. But congratulations, we are through the techniques of integration. You're going to run across some other stuff in the homework, with the whole, what do you do when you see this? And so just see how it goes. All right, maybe I should take attendance. Yeah, let's do it. I'll do it fast. Ready? Just say yes, I'm here or whatever. Mauricio? What's today? The 2nd? Alejandro? Manuel? Jonathan Vasquez? Joshua? Hunter? Hunter Solis? No? Oh, yeah, that's right. Sophia? Priscilla? Ivan? No. Travis? Caleb? Felicia? Rayoma? Abdul? Okay, hold on. You're both here, so wait a minute. Okay, yeah, I've got you both. Adam? You got it. Domingo? Arnold? Alfredo? Rose, got you. Brittany? No. Dalton? Jeremiah, got you. Nicholas? Matthew Gutierrez? Matt? Yes? Okay. Caroline? All right, thank you. Yes.
I just had a quick question. Real quick.
You know, when I watched the video, it was gonna be like a half-minute break on Rocky trivia. Good.
So yeah, I'm not talking about when Rocky's getting hit. I thought it was the Russian guy hitting him, but I think you're right. I think it's Apollo Creed hitting him, and he's like, "You're not so bad." Rocky's saying
Oh, yeah, I
that.
just had a quick
Because,
question.
yeah.
Yeah, I just had a question. You know how to meet the Rocky?
The thing I remember from Rocky IV, he's like, you know, he's not a machine, he's a man. You know, when he finally hurts the Russian guy, cuts him, and then he's like, he's not a machine, he's a
Oh,
man.
that's the coach, right? The trainer.
Yeah, the trainer, yeah. Not Mick. Mick's already dead in Rocky IV.
So, how did you go from this to this? I know it might be basic algebra.
It is, but it's okay. I mean, I usually mention this while I'm doing it, but okay, so let me just ask you this. If I had x squared y minus y, and I ask you to pull out a greatest common factor, you'd pull a y out, wouldn't you? And you would say y, and then you'd say x squared minus 1, right? Okay, so that's basically what you have here. You have x squared, this is like y, and this is like y. So what you're doing is you're pulling a y out. And when you pull the y out, it's actually x minus 1, right? That the whole thing comes out. And then what you're left with is x squared minus 1, right? Do you see that?
Yeah.
That's exactly what's happening. But see, a lot of people are taught that once these match, all you do is you write down, you put this and this in parentheses, and then just rewrite one of those. And they're never really understanding what they're doing. But you're actually pulling an x minus 1 out.
That's what I learned.
Yeah, which is fine. Which is fine, but
That's how I saw it, at least.
Yeah.
it's important to know what the algebraic like method is, or like what's happening, right? Because otherwise it doesn't make sense why that turns into that.
I'm gonna pencil and make a note of that, 'cause
Yeah.
when I get home, I'll forget it.
Yeah, let me erase some of the stuff you don't need.
So here's the.
Yes, sir.
Here's,
Okay, yes, sir. Thank you. You had sent me the picture, right? Okay, very good. Yeah, I still need to put those grades in, so I haven't touched that yet.
and the quiz that we have right now, that's only going to be on 6.3, or is that 6.2 as well? Or?
It's both. It says it on the top, quiz over 6.2, 6.3. So you're going to have both things in there, both methods.
And I don't know if I said here for my name there. I just wanted to make sure.
I didn't. No, you were here. That's why I didn't
Oh,
call.
okay.
Yeah.
Somebody's.
You were on your phone, and I saw you, and I didn't want to.
I was on my phone?
Well, after class, you were just standing. Weren't you on your phone just now?
No, I don't know.
No, that was him.
No, that was something.
Oh, you looked busy, so I didn't even. Yeah, I thought you were doing something.
All right, sir. Thank you.
Okay, have a good one. Yes, sir.
I had a quick question.
Yeah.
Because on Thursday, I had my scheduled appointment with you.
Mhm.
Should we just reschedule it, or how did you want to go about doing it?
Which one? This? I've already. Oh, wait, I didn't stop. I thought I stopped it. Oops. Yeah.